it again. Okay, so the title of this section is Empirical and Molecular Formula Notes. I want you guys to look at the definitions of both of these. Empirical formula is the simplest whole number ratio of elements in a compound, and they give us an example. Doesn't mean much to us yet because we have nothing to compare it to, but whenever you look at molecular formula and it shows the actual number of atoms of each element in a compound, I want you guys to compare these two. You see how with the empirical formula, it's the most reduced form of that molecule. We have 1 carbon, 2 hydrogen, 1 oxygen. If you compare it to the molecular formula, it's really the same ratio, except everything here has been multiplied by 6. So the empirical formula is going to always be reduced. And I would write that down. It's the one that's reduced. And anytime you see the same ratio, but they're like double or triple the numbers, that would be considered the molecular formula. Okay? So then they give us the steps to mathematically find out what the empirical formula or the molecular formula is of a molecule. And honestly, when you're doing your homework, it would be smart to just look at the steps if ever you forget. We are just going to jump into the example, and I think that will help you to understand the steps. But the one thing I wanted to point out is that well, actually, never mind. Let's just do this. Let's try it. Let's look at example number 1. It says, analysis of a compound containing chlorine and lead reveals that the compound is 59.37% lead and 40.63% chlorine. Okay? Looking at the directions, it says for step 1, if given a percent, assume you have 100 grams of the substance. For example, if you had 20.6%, you would make it 20.6 grams if you assume 100 grams. Honestly, you know what this is? It's the opposite of percent composition. We're taking percent composition, they're giving us percent composition, and we're switching it back to the actual original formula. Okay? So let's do this. It says to change the percentages to grams. I would like to go ahead and change it to grams to make it easier for us now that we have followed rule number 1. Okay? Step number 2, find the number of moles of each element by dividing by their molar masses. Okay? So let's do that. I have 59.37. I think I'm going to do a blue pen. 59.37. We just made it grams. All of the percentages are supposed to equal 100% at the end of the day. They will. We're converting it to moles. What is the molar mass of lead? You would have to look it up on the periodic table. And we're going to put, it's 207.2 grams of lead. You know what? I don't have a periodic table. Could somebody bring me one just so I could show it on here? But what I wanted to show you is that it's equal to 1 mole of lead. Anybody bring me one? Okay, you do the math, and most of you are capable of this simple math. It's just going to be division at this point. Thank you. Okay, so look, lead, right there. That's where I got the 207.2. Okay? You're going to do the math, and you would end up with an answer of, and by the way, I'm not reducing this answer. I'm just going to write the whole thing out. Okay? I'm going to take the 40.63 grams of chlorine, and by the way, that top one was lead. Okay? We're going to convert this to moles, and here, when I look up chlorine on the periodic table, it's 35.45 grams of chlorine is 1 mole of chlorine. When you do the dividing, you would end up with 1.15. Now, I could put moles, but it honestly doesn't even matter because at this point, I just want to know ratios. So if I don't put moles, it's okay. Okay, you've done that part. Now, the last part of this problem says, find the smallest moles, divide all the moles by the smallest moles, and this gives us our whole number ratio. This is what it means. Which one of these is smaller? The top or bottom? Top, okay. So what number 3 told us to do is to divide both of these by the smaller number so that we can figure out the whole number ratio of this molecule. And again, I know you guys know how to punch this into your calculator, so I'm just going to give you the answer. When you divide both of them, you get a 1 here and a 4 here. Okay? What this tells us is that if I had lead and chlorine, the empirical formula, the more simple formula, is going to be lead 1, and of course the 1 is assumed, you don't write it down, chlorine 4. Okay? And that is the empirical formula. If I wanted to find the molecular formula, now this is the part that people get stuck with. They get confused. In the problem, it says the molar mass of this compound is 349.01 grams per mole. Okay? What is the empirical formula? What is the molecular formula? Well, if you add this up from the periodic table, you have the 207.2 from the lead, and there's only 1 of them, plus 4 of the chlorine, which are 35.45. Okay? When you add them up together, they equal a total of 349. Okay? So in this case, it turns out the empirical formula is exactly the same as the molecular formula because they have told us that it weighs 349. And so I'm going to go ahead and write that down. But what I want to do is ask you this. If they had told us that the mass of the molecule is 700 grams, what would the molecular formula be at that point? Would everything have to double, triple, what? Anyone? Okay, it would have to double. If I told you that the mass of it was 700, like if that was the way that the question was asked, you would know that everything here is doubled, okay? Let's try this next example, and I really think you'll have a better idea of what I'm talking about. Just the more you do it, the easier it gets. Glycerol is a thick, sweet liquid obtained as a byproduct of the manufacture of soap. Its percent composition is 39.12% of carbon, but I'm changing it to what? Grams. 8.75% hydrogen, I'm changing it to grams. And 52.12 grams of oxygen. Let's change it from now. Let's change the original question. Let's make it where the molar mass that they give us, you will have some of these in homework. Let's make it where it's 184 grams per mole. Okay? What is the empirical formula? What is the molecular formula? Okay, so the first step is to take each individual element and convert it to moles. So carbon would be 39.12 grams of carbon. Do we have it memorized now? What is the mass of carbon? Anyone? Yell it out, people. That would be oxygen. Okay, carbon is 12. 12 grams of carbon for every 1 mole of carbon. Okay? you would do the math. The next one is hydrogen, 8.75 grams of hydrogen. For every 1 gram of hydrogen, it's 1 mole of hydrogen. By the way, this is where I'm getting these numbers. Chlorine is 12, hydrogen is 1, and I'm about to do oxygen, which is 16. Okay? So they give us 52.12 grams of oxygen. For every 16 grams of oxygen, we have 1 mole of oxygen. Okay, you do the math, and this is what you would get. 3.26, 8.75, 3.25. Then you ask yourself which one is the lowest number of all of those answers, and it's what? First, second, or third? Third. So you're going to divide all 3 of them by that 3.25. Now, this one is a little bit different. You're going to get a whole number. This one is 2.69, and the last one is 3. But what I wanted you to realize is you cannot have an empirical formula that is equal to 1 carbon, 2.69 hydrogen, and 3 oxygen. You can't have fractions in your molecules. So this is where you would have to look at the last step that tells you what to do. If you do not get whole numbers for step 3, use the following to fix it. Okay? If your answers had ended up with a 0.5, you would take everything and multiply it by 2 in order to get a whole number. If it ended in a 0.25, you'd multiply everything by 4 to get that whole number. Well, in this case, it's 0.69. There's nothing exactly 0.69, but there's something close. It's the 0.67. If we multiply everything by 3, then you can get whole numbers. Okay? Now, here's the thing. It's not 100% exact, but it's close enough to give you a whole number. Now, listen to me. You do have to memorize this little chart for the test, but it's really not that bad because what you're going to discover is you're just going to have to find the number that would spit out a whole number. Okay? So, if these were our answers, what this chart tells us is to multiply each and every one of them by 3, and you would get a whole number. Okay, question?
Why would you get 3 for that last one down there? When it's 3.25 divided by 3.25?
Oh, sorry. Thank you. Thank you. It was a 1. Thank you so much. Okay, and is that what you were going to say too? Okay, thank you. Okay, so once we multiplied everything by 3, it's getting kind of messy here. So the first one, carbon, you'd end up with 3. When you multiply 2.69 times 3, you'd end up with an 8. When you multiply 1 with 3, you end up with a 3. So what is the empirical formula? How many carbons? 3. How many hydrogen? And how many oxygen? 3. Okay, but now to find the molecular formula, you can't really find it unless you know the mass of this. Okay? I'm going to do it down here. Let's do molecular mass of the C3H8O3. If I have 3 of the carbons, which weigh 12, I have 8 of the hydrogen, which weigh 1 each, and I have 3 of the oxygen, which weigh 16 each, your total molar mass of your empirical formula ends up to be 92 grams. Okay? But we are given 184 grams to begin with. Okay? So what does that tell us the molecular formula would have to be if it weighs double what we have? What would we do with everything in the molecular formula? Double it. Okay? So the molecular formula would be C6H16, oxygen 6. Okay? Now, you're going to have 10 problems to practice for homework, but when in doubt, you could always go back to the 4 steps to follow. Okay? You all have a great weekend.